They are beautiful, they appear in a large variety, and they make children happy. Today we want to discuss the physics of soap bubbles. In order to understand the phenomena behind soap bubbles, we first have to take a look at ordinary water. If we assume the water to be pure, then this water consists of an uncountable amount of small particles called molecules. However, molecules are by themselves combined objects of smaller quantities called atoms. Each molecule consists of one large atom called oxygen and two smaller atoms that are named hydrogen. The electrons in their outer shells glue them together very tightly. Because of the huge difference in their sizes, the oxygen atom pulls some of the negative charge from the hydrogen in its own direction. This induces a dipole structure with a slightly negatively charged oxygen and a slightly positively charged hydrogen. Due to repelling effects of the charges, the bond angle of the hydrogen atoms is given precisely as 104.45 degree. Both mentioned effects cause strong interactions between the water molecules. Because they are stronger than in other materials, they have a special name and they are called hydrogen bridges. This strong coupling between the water molecules creates a thin skin on the surface which is called surface tension. In this video you can see an object swimming on the water. After filling a little bit of soap into the water, it immediately sinks down to the ground. The uplift force is therefore too small to let the object swim, and the reason for that can only be found in the existence of surface tension. The soap contains a special kind of molecules called surfactants because they change the property of the water surface. They consist of a small part that likes water and is therefore called hydrophilic. The other part contains a long chain of carbon and other atoms and cannot be solved in water. It is therefore called hydrophobic. The hydrophilic part can be interpreted as their head, whereas the hydrophobic part looks like a tail. The interaction between the tails is very small compared to the hydrogen bridges in the water. Therefore, the surface tension of water is highly reduced. In this video, dish soap is filled in a cup of water. A drinking straw is used to mix both chemicals and create soap water. By blowing into the straw, small bubbles are created, which would not be possible for pure water because of the high surface tensions. By the way, soap bubbles do not remain forever. Due to the gravitational force of the Earth, the water flows down to the lower part of the bubbles until the skin on the upper part gets too thin to remain stable. In the outer space, far away from any gravitational influence, as for example in the International Space Station, soap bubbles should be able to remain a much longer time.